Yeah, welcome to Taxonomy Online Mathematics YouTube channel. Today we are continuing with our tutorial on set and operations on set. Today being the third episode, we want to take the properties of the operations on set. Now we know the properties on the operations on set are three: commutative, associative, and distributive properties. We want to take each of them and see how we can operate them on a given set. If you have not subscribed to the channel, please, I will indulge you to subscribe. Click on notification bell for more notification when a video is uploaded. Like, share, and comment. Come along as we begin. Alright, so we are taking the first one, which says commutative property, or we can say what? Commutativity property of what? Set. So we are saying that the union of a set and that of the intersection of two given sets, which could be A and B, are commutative. If that is it, so we know that is A, if I start with this, union B. A union B should be the same as B union what? A. And if I move away from union and want to move into intersection, that could also be written as A intersection B should be equals to B intersection what? A. Commutative property simply state that the order in which the operations are operating on two given terms does not change the result. Meaning, if I start from A intersection B, the result should not change if I change the position of A and B. So if I have a given set, if I have a set A, let set A equals to, let's say we have 2, 4, 6, 8, and we let our set B equals to 1, 2, 3, 5. If these are the two sets, for me to prove that A union B is the same as B union A, we find out what will be the union of this set. Taking the first one, A union B, meaning combining the two sets, writing in ascending order from the smallest to the highest. So combining A and B, I know 1 is smaller, so the set of 1, 2, even though 2 appear twice, you write only once. The next smallest number will be what? 3. Then we have 4, 5, 6, and 8. That will be A union B, combining the set A and B together. What if we want to change the order, meaning B union A? Still, it is still a combination of the two sets. We are combining the two sets. Set A, set B, writing in order. We can still look at it that the 1 will be the first smallest number, which will still follow the order we are having. So A union B is the same as B union A in terms of commutative property. The order does not change if the operation remains the same. So since the operation remains to be union, the order does not change the result. Similarly, if I'm looking for A intersection B, A intersection B, looking at the two sets, what are the common elements or members? So looking at A, 2, 4, 6, 8, 1, 2, 3, 5, I can see that the only element common to the 2 will be the element 2. That is A intersection B. If I change from B intersection A, still I'm going to look out for common element belonging to the two sets, and that will still leave us what? 2. So this proves that the commutative property which says that A union B is the same as B union what? A. And the same time, A intersection B is the same as B intersection what? A. So that is for commutative property, which we know under operations, whereby it is addition or multiplication. The order does not change the result if the operations remain the same. That is commutative. Let's take the second one. Alright, for the second one, we have associative property, which in this case also the union of a set and intersection of a set are both what? Associative. Alright, so if we have any given three sets, which is A, B, C, we can also see that A union B union C, as we take the last two, meaning as we take the set B union C, the result you will have should not be different from A union B union C. No, in the previous property, we were dealing with only two sets. For commutative, two sets, A or B or A. In this case, we are dealing with three given sets with one given operation, where the operation could be union, or we could also have a situation whereby A intersection B intersection C, picking the last two, the results will not change when we have A intersection B intersection what? C. We know under board mass we operate bracket first before any other term associated. So if you are taking this, whereby the last two is taken with the first two is taken with the last, the results will not change. Don't forget, we are still dealing with what? In one breath, as in this breath, we are taking of what? Union throughout. And in this breath, we are taking of what? Intersection throughout. So if we have a set, let's say, alright, let's consider this. The set A 1 3 5 7, B 2 3 6 7, and C 4 5 6 7. Now, if you want to take the first method, that is the first relation, which we are going to take the first part, which will be A union B union C, whereby we need to take the one in the bracket first. So dealing with B union C, we are going to look at for combination of the set B and C. What are the elements combined together? So B and C, starting from the smallest, will be 2, 3, 4, 5. So combining the set B and C, we have 2, 3, 4, 5, 6, 7. Now let's combine this with the given set A in order to have this, or let's combine the set A with the B union C and C. So in this case, combining this and this, we start from the smallest one. So I believe 1 will be the first number, 2, 3. So in that case, we are going to have 1, 2, 3, 4, 5, 6, 7 combined together, as in A union B union C, taking the last two before the first one. Now we want to see that if this set as we have will be the same as taking the first two before the last one. So taking this, so now we take the A union B. A union B, beginning from the smallest one will be 1, 2, 4. Okay, we don't have 4. So 3, 5, 6, and 7. In that case, A union B is giving us these numbers without what? 4. So now we are going to combine this, the A union B as we are having, we are going to combine it with what? C. So this set we are having here with the set C. 1, 2, 3, we know we have 5, 4, 5, 6, 7. So that is going to be 1. So looking at these two sets, as in this and this, we can see that 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The two sets are the same. So under associative property, we can say that A union B union C, taking the last two first, is the same as A union B union C, taking the first two first. And bear in mind that we are dealing with three sets with a single operation. In the previous one, we were dealing with what? Two sets with a single operation. Similarly, we are having three sets with a single operation. So that will lead us to the first one. Now, that is union. Now, let's check whether this set can also be verified on the intersection. So for the intersection, we can take A intersection B intersection C, whereby we are taking the last two. So beginning with B intersection C, what are the elements common to both B and C? 2, 3, 6, and 7. So we can see that we have 6, 7 as the only intersection element. Then we're now going to intersect this set with set A. Looking at this 6, 7, set A, intersection 1, 2, 3, 4. I think the only number common is 7. So A intersection B intersection C have the element to be only one, 7, a unit set. So 7 is the only set we are going to have. Let's take it to the right hand side. A intersection B intersection what? C. Whereby we will consider the one in the bracket A intersection B. If I compare the set A and set B, what are the common elements? I think I have 3 as a common element. 5, no. 6, no. Then I have what? 7. So now 3, 7, as in A intersection B, will now be compared with the set what? C. 3, 7, 4, 5, 6, 7. I believe 7 is the only intersecting element. Therefore, A intersection B intersection C will still give us what? A unit set. Hence, A intersection B intersection C will be the same as, which also prove that intersection and union are associative property. They can be associated. In pairing, the order does not affect the result if the operation remains the same. That is in case of associative property. Let's go for the last one, which will be distributive property. Alright, distributive property is also based on 3 given sets. So for any 3 given set A, B, and C, the union of the set is distributive or distributed over the intersection of the set. So that is, if I have A union into bracket B intersection C, for me to distribute this over this, we know we want to open bracket, the term outside the bracket, multiply each of the term in the bracket. So seeing this is an operation, is going to be, this will be equals to A union B intersection A union what? C. So we can say that our union is distributive or distributed over what? Intersection. So now, what we are saying is that solving these 3 sets in this form, the result you will get will be the same if you have this set as in 4 sets, 2, 2, and intersected on each other. The result will be the same. So if we let our A to be if we are having these three sets as we have for the associative property, we want to see that this intersection can be verified. Let's take it for our left hand side, picking the one in the bracket first. So I'll be going for intersection of B and C. So B intersection C, what will be the element? If I look at the set B and the set C, what are the elements that are intersecting together? 5, 4, 5, 3, 2 are two different terms. 6, 7, 6, 7. So 6 and 7 are the intersection. So this intersection will be combined with the set what? A. So A union the answer I get as a set. So A, which is 1, 3, 5, 7 union 6, 7. So in this case, A union B intersection C, combining them for the smallest, will produce 1, 3 as the smallest, followed by what? 5. Then we have 6, 7. Combining the set A, which is here, with the result we had from here, will produce 1, 3, 5, 6, 7. So we are done with the left hand side. So now we need to work on the right hand side to be able to produce the same answer for the property to be verified. So I will take the first bracket, which is going to be A union what? B. A union B, combining the set A and B, writing in order. 1. I believe I have 2. Do we have 3? Do we have 4? No, but 5, 6, and 7. So A union B will give me that. Let's go for A union C. A union C. What are the elements if I combine A and C together? I believe 1, 3 is here, so we have 4. I believe we have 5, 6, and 7. So A union B, we have. A union C, we have that point. What is the next thing to do? Finding the intersection of these two sets. Meaning, we are going to find the intersection of A union B intersection A union what? C. What is the element that is common to the both sets? So this is going to be written as, I am looking for intersection. So 1, 1, 2, no, we have 3. 5, no, yes, we have 5, but no 4. So 5 will be taken. 6, 6, 7, 7. So A union B intersection A union C. We have 1, 3, 5, 6, 7. In the beginning, we also have this to be 1, 3, 5, 6, 7. 1, 3, 5, 6, 7. Therefore, this property is verified. So we can say that, therefore, we can easily say that the set of what? Union as an operation is distributive over what? Intersection. The vice versa can be true also, whereby we are going to have intersection to be distributed over union. I will indulge you to follow or use the same set A, B, C to prove or to verify that intersection can also be distributed over union, as in A intersection B union C could be given as A intersection B union A intersection what? C. This intersection, try and see if you can verify that this, as in intersection, will be distributive over what? union, and hit me up in the comment with your finding to see whether are they also verified. Can we say that intersection can also be distributive over union? If that is true, let's get interactive in the comment section, and we will pick it up from there. So all these are the properties of the set operations. The next episode will be how we are going to use Venn diagram, the various regions of a Venn diagram, being it 2-set problem or 3-set problem. Also to talk about De Morgan's law, how we can marry that into our set theory. See you in the next episode as we deal with that. If you have not subscribed, please do subscribe, like the video if you find it educative, and leave your comments, and don't forget to share. Thank you for watching. Bye bye.